Hey everyone, in this video I want to show you how you can use completing the square to solve some trig integrals. So in this one we have the integral of 1 over x squared minus 4x plus 7 times dx. So what we're going to do is we're going to focus in on this denominator, and we're actually going to break it apart into two pieces. Our goal is to have a squared piece that has an x in it and a squared piece that's a number. Essentially, all of our inverse trig functions look something like this, where there's an x squared and a constant piece squared. It might be adding, it might be subtracting, it might be inside of a square root, but essentially that's what we're going for. So we're going to look at this problem over here, and we're going to just rewrite it, but we're going to leave a blank right here and right here. Let's change colors. So now when I would complete this square, I would need something here that's going to condense into something squared right there. And that's going to be this piece right here. So essentially, it's just half of this value squared. So half of that value is 2, and 2 squared is 4. I have to keep this whole denominator the same though. So if I added 4 here, I actually have to take away 4 over here. So now this is going to be x minus 2. Essentially, whatever number was here, not yet squared, so the number 2. And then over here, I have plus 3. So I definitely see this x quantity that's squared, but I don't see this a that's squared, this constant. So this is going to stay the same, but what number squared gives me 3? Well, that would be the square root of 3. So this is what we're going to put back into the integral. And now this looks like arctangent. So the rule for arctangent is we would do 1 over the a value, arctangent x over the a value plus c. And again, when we look at the x value, we're talking about that guy. When we talk about the a value, we're talking about that guy. So the answer to this is going to be 1 over a, which is the square root of 3, arctangent of the x quantity, which is x minus 2, divided by the a quantity, which is the square root of 3, plus c. So by completing the square, we have essentially worked around and made this into an arctangent integral. And you can do this for a number of instances. You can do it if there's a negative involved. So let's look at that situation. So let's say you had, or not a negative, but let's talk about just a leading coefficient that wasn't 1. So 2x squared minus 8x plus 10. So again, we're assuming this is in an integral. Put that right there. And now, how would you complete the square for this? Well, you'd pull out the 2, and then work on completing the square from there. So 2x squared minus 4x, leave a blank, plus 5, and again, leave a blank. So now we're going to figure out what that blank's going to be, which is going to be half of this value squared. And then you're going to do the opposite over here to keep it balanced. So then you have 2. This chunk right here is x minus 2 squared. Again, our goal is to have that x squared plus a squared bit. and then this would be plus 1. Then from here, you would work it back into your integral. Again, that would probably be a 1 squared there, or a square root of 1, which is going to be 1 still. Another instance that you could have would be if you had a negative. So maybe we have something like this, 3x minus x squared. Again, that would be in the denominator. This would be the integral, something like that. So complete the square with this. Well, that negative put out in front, so that'd be x squared minus 3x. Leave a blank, and then essentially leave another blank for undoing it. So what would this be that we would need to add on? Well, half of that value squared. So half of that value squared. And then do the opposite of it to make sure it cancels out. So this would be negative x minus 3 over 2 squared. And then this can essentially come out in front right here. A negative times a negative is a positive, so 3 over 2 squared. This one would probably be in a square root. So when we were to do this one, it would take on the form of kind of the a squared value minus the x squared. And that, under a square root, is actually going to be arc sine when we do the integral of that. So if this was our problem, we would get out an answer of arc sine, and then it's dx, which is x minus 3 over 2 squared over the a, which is 3 over, oops, sorry, not that squared there, squared's right there. Not right there, square's on the outside. So then 3 over 2 plus. So that's how the negative would work if that was how you're doing your um, integral of that. So hopefully this little video helps with any completing the square things that you might have to do. That very rarely shows up on an AP test, but it does come up. So hopefully these couple examples help you with that. Thanks for watching. Bye.